picking up where we left off yesterday with B. And with these, we're trying to write the equation, if you recall. In this one, we have that the vertex is 3, 4, and the focus is 5, 4.
Actually, I think it's right. The right one. Because the vertex is 3, 4, and the focus is 5, 4, so the focus is 2 units to the right of the vertex.
Okay. So, and in that, he's essentially visualizing a picture. There's 2 ways we can go about this. We can try to use the chart. We can sketch a picture to get us going. Okay. If you look at the chart, 3, 4, and 5, 4 as vertex and focus. So if I go back up to the top here, 3, 4, and 5, 4 are my vertex and focus. So notice with 3, 4, and 5, 4, which piece is the same here? The y value, yes. So notice that means that k value is 4, and as we go to look at focus, where else is the k value 4? Right here, as opposed to k plus p. Now, if that's not exactly making sense, here's what I'm going to say. I'm going to say, sketch a picture. It doesn't have to be fancy. It's just the visualizing. And if you can visualize this in your brain without the sketch, that works great too. Okay, so if I put on here, okay, so what do we have? We have a vertex at 3, 4. Like yesterday, I'm going to put a V for vertex just so I can keep myself organized. We have a focus at 5, 4. Okay. There's my visual. That's going to give me the idea of which way my parabola opens. Parabola goes through the vertex. Where is the focus when we draw a parabola? Do you remember this from yesterday?
Like 2, it's like this, right?
But it's
where it opens. It's like inside.
It's inside the parabola, yes? And so the idea here is that when I draw this, if here's my vertex and that's the bottom, well, if I want the focus to be inside, then keep in mind what's going to happen. My parabola is going to have to go and open to the right. So what does that make this? That makes this a right column parabola. Are you with me somehow or another? Because that's one of the big decisions you have to make is left column or right column. Okay? And so, right column. Okay? We're going to fill in that equation here in a moment. What's the formula at the top of the right column we're going to be filling in? In other words, what am I looking for? Top of the right column? That's the equation we're writing. The y minus k squared equals 4p times x minus h. So y minus k squared equals 4p times x minus h. Now, we were given the vertex and the focus, yes? We know our vertex is 3, 4. What letters does our vertex represent? Go to the top of your chart. We're working with vertexes that are at what?
H and K.
H and K. So anytime you have the vertex, think HK. So right here, my vertex is H comma K, which what does that mean H and K are? 3, and 4. Are we okay with that? Vertex was given us 3, 4, and it doesn't matter which column you are. Vertex is HK, so H is 3, K is 4. Now, focus. The vertex is HK. What's the focus according to our chart? So go back up top. What's my focus going to be according to the chart? We're working in the right column. Is this parabola opens right or left? My focus is going to be H plus P, comma K. So H plus P, comma K. My values for the focus are 5, 4. Okay. Now, here's where I need you to get. We have to know 3 things to write this equation.
Oh, so you know.
We have to know H, we have to know K, and we have to know P. We already talked about H and K, yes?
P would be 2 because we know that H is 3.
Can you guys follow Logan's argument? Okay. That's where I'm trying to lead you, in that right here, we know that H plus P has to equal 5. Okay? If we already know that H is 3, then, yeah, you're at 3 plus P equals 5, and thus P equals 2.
Are we going to get these equations when we make a test?
Yes.
Thank you.
Now, there was another way that we could have figured out P. And actually, it was mentioned earlier. If you look, if I go back, I'm trying to decide where I want to go back to. The focal length is P, right? Now, let's go back to day 1 and the definitions. Focal length. Focal length is the distance from vertex to focus. Focal length, and you can't really see it on here, but it's the distance from vertex to focus. How far apart are my vertex and focus?
2.
They're 2, yes? So right there, because I knew that distance in between the vertex and focus are 2, right there I also know that P is 2. Now, here's what I'm trying to do, guys. Everyone's brain works a little bit differently. I'm trying to give you different options of here's where you can find P. Okay? Some of you are going to be like, oh, hey, I saw that distance being 2. That's easy. Some of you aren't going to catch that. Some of you are going to be like, oh, I like being able to set up this formula here. Okay? You have to do you. Everyone's going to do these a little bit differently. Some people are going to say, oh, I have to draw the picture. Some people are going to say, picture, that's a waste of time. I don't need the picture. Okay? I'm trying to cover all my bases. Fair enough? So hopefully, fingers crossed, I'm going to reach everybody. Okay? Did you write your final equation? What do we know to fill in? K is going to be what? 4. P is going to be 2. And H is going to be, I forgot what H was. 3. Now, also, do let me comment though. If you just use the drawing to figure out that P is 2, this parabola opens right. Opening right is like opening up in that P would be positive. If this parabola opens left, you have to know that P would be negative, just like it would if a parabola opens down. Okay? So, okay, write your equation if you have it. Y minus 4, quantity squared, equals 4 times 2, or in other words, 8 times x minus 3. And generally you leave it in that form. That is your standard form of a parabola that we're, leaving it as. Okay? Questions there I can answer. It's going to take practice, isn't it? Okay, let's look at C. I need to write an equation for a parabola that opens left, has a vertex of negative 3, 2, and a focal length of 2. Okay. Any thoughts?
So, P would just be 2 again, wouldn't it? Because the focal length is 2.
Okay. You guys check that chart, right? Focal length is 2. And so, remember focal length? What I pointed out on the previous page, that is the distance between the vertex and focus. So that does give us the idea that focal length is 2. There is a little bit of a catch though. What do we know about the opening of this parabola? It opens left. What's that going to impact? It makes it negative. Okay. Just like a parabola opens downwards has a negative coefficient, a parabola that opens left has a negative coefficient. Okay, so as I talk about this, I'm going to say that P is negative 2, and it's negative 2, or it's negative, I'm even going to write it on here, because it opens left. Okay, so that says negative because it opens left. If it opened right or opened up, it would be positive. It opens left or down, it's negative. Okay, so we know our p-value. What else do we know?
H and K.
Okay, we know our vertex, yes? Our vertex is of the form HK, and we were told our vertex is negative 3, 2. So we have H, we have K, we have P. We never talked about this, it was fairly obvious, but which equation do I need? Which column am I working with?
The right column.
Because my parabola opens left or right, we're in the right column again, which means again we are using the y minus k squared equals 4p times x minus h. Okay. So we know that p is negative 2. What was h? H is negative 3. And k is 2. Okay. Y minus k squared is going to be y minus 2 squared equals 4 times negative 2 is negative 8. What about x minus negative 3?
X plus 3.
That's x plus 3. Now, real quick before I turn the page, it didn't ask us to, but I'm just trying to get us familiar. I'm going to sketch the graph. Just make sure you guys have the visual of what this graph should look like. Okay. We know the vertex is at negative 3, 2, yes? This parabola opens left, yes? Tell me where my focus is.
It'd be negative 5, 2.
Okay. If my parabola opens left, yes? It opens that way. The focus is a point inside the parabola, and it has its distance from the vertex is the focal length. So it is 2 over, so it does end up being at the negative 5, 2. Okay? And I know, it didn't say to draw a picture, but I'm just trying to help you make all the connections. Okay? Because you're going to go home and do homework tonight, and you're going to come back with some questions tomorrow. Okay? I've tried to show you some options, some, the variations, but it's going to be a homework that we're going to have questions on. And I expect that, but I need you to go through and try all the problems and look at the different setups and see what you can come up with. Okay? Okay. One more page. There's the third page to this set of notes. And that is graphing these parabolas on the calculator. Now, as you look at the ABC options we have here, what has to be true to graph something on your calculator? Has to be y equals, yes? Are any of these y equals? No, of course not. That's the trick, okay? That's what makes these tough, is that they're not y equals. And so, there's some steps here. We have to solve for y. It does throw out the idea you might have to complete the square to do this. Okay? It doesn't necessarily have to be pretty. It just has to be something that's y equals that I can type into my calculator. You'll type the equations into y. You'll see this when it happens, but we might have to type 2 equations in even. That'll make sense when we get there. And then we'll graph it. Okay? Now, let's look at A, because we've got 3 different versions here, all a little bit different. Graph this on a graphing calculator. Y minus 4 squared equals 8 times x minus 3. How do you work to solve for y?
Square both sides.
But you don't mean square. Y minus 4 is already squared, so we want to take the square root, right? My goal is to get y by itself. So the first thing I want to do on that y minus 4 squared is get rid of the square. To get rid of the square, we're going to take the square root. What we do to the left, we do to the right. Now, what is the square root of y minus 4 quantity squared? Y minus 4. What's the square root of 8 times x minus 3?
Square root of 8 times x minus 3.
Okay. And what does your math teacher always say to do when you take the square root in the equation setting? Every time, guys. I did this in Algebra 2 a lot. When you take the square root in the equation setting, you always have to put on a plus or minus. So I'm going to write this as plus or minus the square root of 8 times x minus 3. Now, how do you solve for y? If it's minus 4, we're going to add 4. When I write this, y equals, you guys have been with me. Remember, I like to have my plus and minus in between two things. It just makes sense to me. So I'm going to write this as 4 plus or minus the square root of 8 times x minus 3. Now, I would be happy with that as an answer. Your calculator will be more than happy with that. Technically, there is a little bit of simplifying you can do with that square root of 8, but I'm not going to worry about that. Now, we type in on the calculator, yes? What's the catch? Yeah. Do we have a plus minus button we can use? I keep thinking this calculator should have one. It's fancy enough it should, but it's not there. So you have to do y1 as 4 plus the square root of 8 parentheses x minus 3. And then you're doing 4 minus the square root of 8 parentheses x minus 3. So y1, I made 4 plus the square root of 8 times x minus 3. And y2, I made 4 minus the square root of 8 times x minus 3.
So what's the goal after you graph it? This says graph.
Okay, so the goal is just to graph it. What I'm going to expect to see in homework is, first of all, appropriate solving work, and then a sketch of your graph. Now, first of all, I'm assuming your graph showed up like my graph did. Notice what's happening over there in the area of the vertex.
There's a hole.
That's not connecting exactly, right? Now, and this is where we know this is a parabola. Assume that it connects there. Okay, that is just how the calculator works. And when you have two graphs like that, it's not going to connect exactly. But know that that is a typical parabola. Okay? Now, it's a sketch of the graph. It doesn't have to be fancy. Just try and make it appropriate. Vertex. Where's that vertex look like it should be? Or
3.
I'm going to argue that we knew from the minute we started where this vertex is supposed to be. Why do you say 3, 4? Okay. You guys see what she's talking about? H and K. Now, you won't always have that, but because that's H and K, I do know my vertex is supposed to be at 3, 4. Okay? You won't always have that, but it's nice when you do, right? Okay. So, and I'm not looking for anything fancy here. A graph. Trying to get it in the proper position, vertex in the proper space, opening the right direction. Past that, I'm not going to be that technical with these. Fair enough? Okay. Give me something. Try and put it in the right spot, the right direction, and that'll work. Okay, and it's helpful to have the vertex in the appropriate spot or label. I guess I didn't label this one, but I have it over there. Okay, questions on that one? That's one type of solving you might have to do. Okay. I'm ready for B when you guys are. You ready for B? Thoughts on how to solve this for Y?
You gotta subtract the x squared, add the 7x, add the 2, divide it all by 3.
In terms of Y terms, what do we have in this problem? We just have a single 3Y, yes? How do you get 3Y by itself? You move everybody away. So, subtracting x squared, adding 7x, and adding 2. So we're going to subtract x squared, add 7x, and add 2. In that case, at that point, I'm going to have 3y equals, clean this up. There's one slight cleanup that can happen here when we add and subtract those terms over, yes. I'm now going to say negative x squared plus 7x and plus 11. And then, as it was stated, divide by 3. Now, okay, big picture. We're plugging this into our calculator, right? I wouldn't do anything fancy with it. To me, it's going to be one big fraction. Negative x squared plus 7x plus 11, all divided by 3. Okay, I don't see any reason to make it fancier. Graph it and see what you get. If you're not a fraction bar user, which I think most of you probably use a fraction bar, your entire numerator needs to be in parentheses, right?
On the vertex, you could just hit max.
Yes, you can. That's going to be my suggestion here. Okay, hopefully your parabola is looking like mine. Does this parabola make sense? It was just y equals a negative x squared term, yes? So if it's y equals negative x squared, well, y equals x squared, those are our up and down parabolas. A negative means it's going to be down. Okay. And then in terms of trying to get this positioned properly, I do agree that in this particular parabola, you can find the max, can't you? Did you guys find the max? Remember second trace, max, left bound is to the left of your max, right bound is to the right, and then your guess, which you can just hit enter. And interesting, a decimal and then a fraction. So the max is about where?
3.5, 7.75.
Okay, 3.5, about 7.75. Somewhere around there on mine. Okay. 3.5, 7.75. My problems when I draw them like this never turn out pretty, but I'm ballparking it. I'm getting it in the right area. That's what matters. Okay, so I want to see appropriate work and a sketch of your graph. Okay? Sketch of your graph tells me that you did take the time to graph it on the calculator. Okay, one more. Y squared minus 6x plus 2y plus 13 equals 0. Thoughts on how we want to start solving this?
First, no, let's see, we haven't completed the square yet, so we might have to do that.
He does have a point. Completing the square was hinted at the top. And it hasn't happened yet.
I'm going
Now.
to go with completing the square. So issue.
Okay. So, okay, go with the basics though. When you're trying to solve, what are we trying to solve for? Y, right?
Mhm.
What's your general first step to solve for y? Because that's the general first step I'm going to take here. You want y's on one side, everybody else on the other side. Now, in this catch, what's different about this one? We have a y squared and a y. That's where completing the square comes into place. But so I'm going to add the 6x and subtract the 13 over. Okay? So I'm going to have y squared plus 2y are going to stay on the left. I'm leaving a gap. Equals 6x minus 13. Okay? Now, this is where we run into the problem. This is why completing the square is going to come up. We have y squared plus 2y. You can't take the square root. That helps with the y squared, but not the 2y. You can't divide by 2. Like, there's nothing you can do here. The way it is. There's not just an easy small solving step. So we're going to complete the square. Now, in order to complete the square, okay, dig deep. You were taught it last year. I taught it again this year. How do we complete the square? B over 2 squared. So B over 2 quantity squared. What is B?
2.
B is 2. So 2 divided by 2 quantity squared. 2 divided by 2 is 1. 1 squared is 1. What do we do with that 1?
Add it.
You add it on the left.
Subtract it over.
If you add on the left, you also add on the right.
But then there was one version where we didn't.
Okay, so the version where we did an add and a subtract was when we were working on the same side of the equation. You're working like inside the parentheses and outside the parentheses. We're working on two sides of the equation with different sides of the equation. What you do to one side, you do the same to the other side. Okay? So I'm going to add 1 on the left, add 1 on the right. Now, on the left, the whole idea is we just completed the square. We made this a perfect square, so this factors into a perfect square. Think like product and sum, right? Or, I think square roots. What's the square root of y squared?
What?
Y. What's the square root of 1? 1. The middle sign, the sign on the 2y is a plus 2y, so this is a plus 1. Or it's the idea of 1 times 1 is 1, 1 plus 1 is 2, right? The right I'm just going to clean up. 6x minus 12. And what do I do? Okay. We're kind of like we were at the very first problem of the day, or first problem of this page. If it's y plus 1 squared, we're going to square root. You square root the left, you square root the right. Square root of y plus 1 squared is y plus 1. What's the square root of 6x minus 12? Plus or minus the square root of 6x minus 12? You'll figure it out when you go in to type it in your graph. You only get half a parabola. Okay? How do we finish solving for y? It's y plus 1. I'm going to subtract 1. Y equals negative 1 plus or minus the square root of 6x minus 12. Okay? Now, well, I'll show you in a moment. There is another way I can write that. Slightly different. They'll help you see the vertex there, but this is going to take a y1 and a y2, right? So negative 1 plus the square root of 6x minus 12, and negative 1 minus the square root of 6x minus 12. Okay. Your parabola should be kind of looking like my parabola when you get there. Any fancy knowledge of where that vertex is?
No. It doesn't look like it's going to connect that like an actual point, but it might.
It does.
Could you do factors with 6x minus 12?
It would be factor, but yes. And that's how I was also going to write it, and I just, I'm going to have to move this graph up a little bit. Another version of this is y equals negative 1 plus or minus the square root of, and then under that square root, make it 6. And if you factor out that 6, it's then x minus 2. Okay, now this isn't back in your normal form, but when we see this, there's a 6x minus 12, a y plus 1. Where's that vertex ending up at? What's it, 2, negative 1? Okay, you can see the 2 right here. You can see the negative 1 here. Or you can go back right there and see it. Okay. So, again, not that you have to catch that, but it's helpful when you do, right? Parabola looks something like that. It is a vertex of 2, negative 1. Okay? Okay, guys. Your homework. 7 through 10, 12 through 30 evens, 40, 42, and 46. I believe those numbers in the 40s are what we just did of this back page. Okay, the 12 through 30s are more of the writing the equations. And that is 12 through 30 evens, though.